Scientists using computer models are able to accurately predict future climate events. Scientists using computer models are able to accurately predict future climate events. I have a new chair, huh? Okay, do I have a timer? Would you please? Can you all move toward the podium a little bit? Yeah, good. Yeah, that's better. Okay, the chair will now recognize the leader, the Prime Minister of the government, for a speech not to exceed 7 minutes in length.
Hi everyone, my name is Michelle.
Hi, Michelle.
And I will be arguing as a proponent for the topic of scientists using computer models are able to accurately predict future climate events. The definitions will be defined within the context of this brief. The criteria is that the accuracy of any forecast is to be evaluated using 3 criteria: the place, where it will happen, the date, when it will happen, and the severity, how bad it will be, and how much damage it can cause. The value for disaster prevention is human life. The statement of arguments. The first argument I'm going to make is based on whether computer models are able to accurately predict future climate events, and emphasis on accuracy and the question of reliability. First, I propose that past events are reliable indicators of future events. History has a tendency to repeat itself, especially in nature. This is because nature adheres to its own rules, and its cycles are consistent throughout history. For example, heat, hot air rises, cool air sinks. Evaporation, condensation, and precipitation. All of these things have been happening for millions of years and will continue to happen in the future. So then, climate events are merely part of these processes. Precipitation or rainfall is part of the process of evaporation, condensation, precipitation, as determined by people for practical purposes, such as agriculture. Then, wouldn't it follow that climate events are consistent? For example, rain in rainforests, earthquakes in places near fault lines, and tornadoes in the Midwest. There is a long history of these things happening in the past, and we can safely assume that they will happen again in the future. So then, what can a computer model do for us? A computer model can use data from past events to project into the future. For example, earthquakes. Vladimir Kozlobakov from the Institute of Earthquake Prediction Theory and Mathematical Geophysics, he writes in 2013 about a pattern recognition algorithm called M8, named to predict magnitude 8 earthquakes. Was designed in 1984 and released globally in 1992 for real-time experimentation. M8 uses retroactive analysis or backtesting to predict magnitude 8 earthquakes, which means it is first tested against historical data. Once it can predict the past, then it can predict the future. In conjunction, there is also a development of the M8 MSC, which also uses retroactive analysis, and this is used to reduce the alarm zone issued by M8. Since 1992, M8 and M8 MSC in combination has successfully predicted a number of earthquakes. The first prediction came in December 7, 1988 in Armenia with a magnitude of 6.8. Another prediction came in California in 1985.
Use the sideboard there, yeah.
So can I draw this?
You're ruining my background.
Sorry. before the earthquake prediction. This is my attempt to draw California.
There's a chair here, Danielle.
So the M8 algorithm has locked out. It says within this area there will be a big earthquake. And then with the M8 MSC, it has narrowed it down to about here. And then the 1989 earthquake of Loma Prieta occurred about here. So it did occur within the area specified by the M8 MSC, and it was, you know, this area is pretty good, considering that it was developed that long ago. And secondly then, which brings me to my next point, what if a model commits an error? Does this make its predictions worthless? An earthquake analysis 2012 paper developed by the International Journal of Disaster Risk Reduction said that in 2001 an alarm was issued in Japan for M8+, including the area of northern Honshu and Hokkaido. And I'll attempt to very quickly draw Japan. Okay. So then, what happened? 70 days before the big earthquake, a small change in value caused the M8 algorithm to shut off. However, at the same time, there was another algorithm called the M8.5+, which also issued an alarm, and it was still on when the earthquake occurred. So northern Honshu and Hokkaido is about here, and then the earthquake happened off the coast, and it radiated off, and this is where the nuclear plant was. So then very quickly, action was not taken. However, the alarm had been going off since 2001, and if the appropriate decision makers within the Japanese government had access to the information, and if they had taken it seriously, could they have taken precautionary measures in the meantime? Yes, they could have, because 9 years is a very long time. So then, so on my balance that scientists using computer models are able to accurately predict future kind of events. Thank you.
Thank you, I guess. Could you put the curtain back down, please, Michelle? Thank you. Cross-examination, please.
I'm Madison. I'm the
Hi, Madison.
So, do you consider earthquakes to be a climate or geographical or geological event?
It is a climate event.
How do you consider it to be a weather event?
It's considered as a climate event because it affects people.
So your definition of climate is something that affects people?
Because it occurs from nature.
So you think anything that occurs from nature is a climate event that affects people? Sorry, I just want to clarify whatever your definition
comes from nature and affects people.
So, okay. Just moving along with the earthquake argument. So how long has it been predicted that we're going to have a big earthquake in California?
For a pretty long time.
Has it happened?
Not yet.
Not yet, okay. I'm just curious. And then, how do you define accuracy? Because I noticed that there were two different definitions in you guys' view.
As I defined earlier, that the place stays here. Yes.
So conforming to an exact truth or to a standard, that's how you define accuracy?
Yes.
Okay.
Yell louder and face the audience.
If there are errors within models that doesn't quite fit your definition of accuracy then, because that's not an exact truth or standard.
I would define the truth as when the event actually happened.
You define the truth as when the event actually happened. So when events don't actually happen, then there's an error in the models.
Yes, that has happened.
So that has happened in the past with certain models.
With alarm, the success rate is 70% and the error rate is 30%.
So there's an error rate.
Yes, there is.
So that's
as
not...
with all scientific models.
Okay. And then, sorry, a few more questions. I noticed you didn't get to all this stuff in your brief, so... Okay, and so then you go into rainfall predictions and things like that. Yeah, so, unfortunately you didn't get to that. Okay, so how accurate do you think that those have been currently?
Yeah,
Like,
pretty accurate.
so there haven't been any errors that formed an exact truth?
Of course, it's based on probability there are going to be errors.
Okay. So errors, I'm just curious how you define errors and within this frame of accuracy, because there seems to be a discrepancy.
It really depends on what kind of model we're talking about. For the earthquake one, there are two kinds, you know.
Mm-hmm.
But again, I want to emphasize on the success rate, which is 70%, and it has defined.
Okay, so outside of earthquakes, though, which I don't quite consider to be a climate event, outside of that, what about the errors in other models?
In rainfall, it's actually been pretty good.
How do you define pretty good?
Was that in rainfall they tried to define like for how much rain there has been, and they graphed it on top of the model again, and it says that the models outperformed previous versions.
Okay. Thank you.
Thank you very much. Chair now recognizes the Leader of the Opposition for a speech not to exceed 7 minutes in length.
Okay. Hi, my name is Madison.
Hi, Madison.
I'm the Leader of the Opposition. So today I'm going to be arguing that scientists using computer models do not accurately predict future climate events. I define climate as the usual weather conditions in a particular place or region for the purpose of a brief climate change will be defined as a change in weather due to certain events. And accuracy I define as free from mistakes or errors. So my first argument is that computer models do not capture all the factors in a natural system, and the ones that they do include are often not completely understood. Naomi Orski, a scientist at the University of San Diego, has argued that the models have limited capabilities because they do not capture all the factors in natural system, and because of this they are unable to be truly validated or verified. These issues with these models are important because public arena decisions are made based off these models. Climate computer models are also known for not being able to accurately include natural variability in climates, producing exaggerated results, especially when trying to figure out the data on global temperatures created by carbon emissions. Dr. Kevin Trenberth, a scientist who works at the Climate Analysis Section at the National Center for Atmospheric Research, stated that a full climate model system should deal with all of the physical, chemical, and biological processes that occur in nature, but currently they do not. For these reasons, Dr. Trenberth said that by design, these models are just a simplified version of the systems being modeled and are not accurate. An example he gives when this becomes an apparent issue is when a controlled climate simulation is run and it says that there's no rainfall in a monsoon area where it should have actually occurred. Because of the situation, the model would only be able to show an increase in rainfall and not a decrease, even if a decrease is actually what's occurring. Computer models cannot accurately predict surface temperatures as seen in the discrepancy between data and forecasts. Professor Mark Maslin from the University College London in 2012 stated that one of the first inputs into a climate model is the expected accumulation of greenhouse gases and aerosols in the atmosphere by the end of the century. These projections are based on economic models that predict global fossil fuel use over the last 100 years, given broad assumptions about how green the global economy will become. Now, if we're doing predictions based off of our global economy, there's going to be discrepancies with that. As seen with the 2008 economic collapse, sometimes there's things that happen within the economy that aren't predictable. And so if we're having these models based off of the economy, there's going to be changes and it won't be accurate. Another issue that makes it difficult for these climate models to accurately predict surface level temperature has been seen with the NASA satellite observations. It suggests that there's actually a lot more energy lost to space during and after warming than the climate models are currently showing. And that because of this, there's a huge discrepancy in the data, especially over big oceans. James M. Taylor, the managing editor of the Environment and Climate News, also notes that these satellites show far more long-wave radiation, thus heat, escaping into space between 1985 and 1999, more than the models have predicted. Together, these satellites show that for 25 years and counting, carbon dioxide emissions have directly and indirectly trapped far less heat than these models have been predicting. The impact of these discrepancies is seen within the 2007 IPCC report that originally stated for 20 years warming would take place at a rate of 0.2 Celsius per decade, based off of these forecasted computer models. They actually had to end up changing this number in the next report being 0.05 Celsius, which is a pretty big difference. So obviously there was a discrepancy between the models they were using for those reports. Dr. Michaels, the director of the Cattell Institute, someone I've cited before, stated that since 2011 there have been 18 different experiments that show that the IPC climate models have been off by 46% when it comes to temperature CO2 sensitivity. Former NASA scientist Dr. Roy Spencer says that climate models used by the government agencies to create policies have failed miserably. Spencer analyzed 90 climate models against surface temperature and satellite temperature data and found that more than 90% of these models have been off and have over-forecasted the warming trend since 1979, whether they use their own surface temperature data set or the satellite data set. Doesn't matter. Models have also been unable to accurately predict humidity and cloud formation when compared to real-life data. Dr. Trenberg stated, the single greatest uncertainty in climate models stems from their treatment of clouds. The reason for this is because cloud formation has a large variety of cloud types and the variability of space and time scales. Being unable to include accurate cloud information actually has a pretty big impact because it influences the incoming and outgoing solar infrared radiation and their role in precipitation that's being used for these models. Precipitation has also been a source of error for these climate models. Regional models have huge uncertainties because precipitation is highly variable over small scales of time and space. This leads to a large range of potential futures, some of which contradict each other. The issue with this is seen as an example of within the detailed hydraulic modeling of the Menko River Basin using climate model input from the UK Met Office. Model projections changes in annual river discharge from the range of a decrease of 5.4% to an increase of 4.5%. Changes in predicted monthly discharge are even more dramatic, ranging from a fall of 16% to a rise of 55%. As I discussed earlier, these models have failed to accurately predict surface temperatures, which directly correlates to the levels of precipitation, because increases in surface temperature also affects the rate of evaporation. So if these surface temperatures data aren't correct, neither will the precipitation. There were also other issues within the IPC report from 2007. One, as she was discussing, in terms of models being able to predict the past and being able to predict the future because of that. Paul Vads of Bristol University stated that when current IPC models were tested against 4 major climate events from the past, 2 were unable to even get the basic climate down before the shift occurred. And then they had to basically reformat the parameters up to 10 times greater than what would be realistic to produce the actual climate that the model was trying to predict. Models used by the IPCC forecasted that there would be a decline in Antarctic ice when there's actually been an increase to a record high. The IPCC has not been able to explain why these models were so incorrect on this issue, but they did change it in a more recent report. Another statement made by the IPCC in 2007 that they had to change was later proven to be inaccurate in terms of hurricanes and whether they would increase in intensity. And for this reason, and all the facts that I've basically given here, scientists using computer models are not able to accurately predict future climate events. And I now stand open for cross-examination.
Very nice. Thank you. Chair will now recognize a 3-minute cross-examination in front of the podium, please. Stand a little closer together. Thank you.
Madison, do you use a computer?
Yes.
Okay, so
Face the audience.
do you trust the calculations that you put into your computer?
For the most part.
Okay, so you do not deny that.
I would use a calculator over my computer for calculations, but yeah, I use it sometimes. Yeah.
Okay, so what do you define by exaggerated in your?
Well, I stated some of the numbers that they were pretty off on. I didn't get to all of it, but the sea level rise of a 2.33 millimeters was shown, but there was actually no upward trend of that evidence. They had to change what they thought the surface temperatures would be, increasing from 2.2 Celsius to 0.05 Celsius. I mean, those are the numbers, so you can see the discrepancies between the two.
So you think that the exaggerations are significant?
Yes. I mean, either way, they're exaggerations and they're errors. And we're trying to argue whether they've been accurate. So, they've been wrong. Sorry.
Okay. So, could you also define for me what you would say by oversimplified? Would you say that because it's too simplified that it would be inaccurate?
Not that because it's too simplified it would be inaccurate, but because they're not including everything in the natural
So
system.
you're saying that it has to include everything. It requires realize that that's very...
No, I do. I understand that. But part of the problem is if the natural systems aren't being actually modeled, there's going to be errors, and so they won't be able to accurately predict.
So you think that without including all of the variables that it can't be predicted?
Well, the variables they're even including right now aren't accurate, so that's part of the issue. It's not whether they need to include all of them, but the ones they're even using now aren't completely correct. With precipitation and cloud formation and things like that.
Precipitation.
Yeah.
And
The timer is here. Are you giving her time signals? She's looking at me like I'm telling her to stop. How much time does she have left? You have a minute left, Michelle. Okay, thank you, Michelle. Okay, Chair now recognizes the member of the government for a speech not to exceed 7 minutes in length.
I'm going to use the board too.
Free country.
Before I go into the definitions of my debate, because we went through a lot of definitions about accuracy and how we define accuracy and stuff like that, there's one definition that really stands out to me, and I'm going to write it on the board for you guys. So this is important, and this is the basis for my thesis and the basis for my argument. And I can erase it off. This is an acronym. And it just happens to be something that college students like to drink. But that doesn't mean it's not important. And I will explain to you the acronym that you see right here, BEER, in very fine details in a moment. But first, I'd like to go into the definitions in terms that are relevant to this case, which is model, a set of ideas and numbers that describe the past, present, or future state of something. Climate, the usual weather conditions of a particular place or region. The purpose of brief climate change will be defined as a change in weather due to certain events. Now, the opposition had brought a very clear point that earthquakes are not related to climate. I disagree, because earthquakes are related to tectonic activity, and tectonic activity are directly related to atmospheric conditions. So if you have a weak tectonic, you have a weak core, your atmosphere will deteriorate, and the sun will immediately come down, and well, your planet will be gone. So that's how earthquakes are related to climate change. So now my thesis, computer models with updated technology can accurately predict climate events, and the scientists who create them are highly trained professionals. Scientists go to schools, if they're a doctorate, if you guys know, you guys are in academia. How many years? 6 years for a doctorate after your bachelor's? So they are highly trained people who understand the analysis of the computer models that they output, because there's a peer review process that the scientific community adheres to. So that's very important to understand. So, the harms. There are no harms to computer models. Computer models are fantastic. Just because there's a 70% probability that something will happen and there's a 30% probability that it will not, doesn't mean it will not happen. 70% is a pretty good chance. If you told me 70% was the chance I was going to get into UCLA, I would take the 70% instead of the what? 24%, the acceptance rate of UCLA. What would you take? So, to define accuracy, you have to define it in terms of what is best for the situation that occurs. So whether that's tornadoes, precipitation, earthquakes, if you can predict it from above a maximum point, I would say above 70%, like the opposition would like to define it as, because they clearly stated it was 70% versus 30%, then that's what we'll define it as. So now, a 2005 article in the London Times entitled "The Opposition Party Challenge to Give Backing Labour Statute on Science" highlights the importance of science to develop in the UK. The prosperity of the UK depends on a continued sustained focus on scientific strength. That means science creates innovation, innovation increases economic strength. So the scientific models that we see, that are through peer review process, that are through analysts of various scientists, professionals, they're there to make sure that the data is as accurate as it's supposed to be. If it is not accurate, it should not be in credible sources. So now, we're going to, why do you guys have a reluctance to accept scientific models? It's because science has always been reluctantly received by society. Galileo Galilei, a famous promotion of the Copernican theory, was persecuted by the church for his heretic beliefs. This is from the Stanford Heritage, 2005. Galileo's scientific and empirical research threatened the authority of the church. So it's all about continuality, right? Cognitive dissonance. If you have a belief that you want to adhere to, you're not going to want to change that belief, right? But science is chaos, as my friend will tell you briefly. And it will change, because chaos, when there's chaos, there needs to be reason. When there's yin, there needs to be yang. And reason is science, and it's fact. And this is a fact case. Not a policy case, it is a fact case. And reason is with us. So now, I will skip all the way to my, for the allocation of time, I'll skip all the way to my conclusion. Now, I will briefly explain to you what all you guys have been wondering in the back of your head, the acronym, BEER. So B. B stands for the benefits. Increase competencies in scientific computer models, eliminate the needless biases that are associated with scientific growth. This will outline the core beliefs of scientific computer models. Science is reason. Reason eliminates that cognitive dissonance that you have. Scientific computer models provide an accurate model for climate events. Scientists are professionals which adhere to the core competency of the scientific process, the future educators of climate change. They're going to come up, they're going to say, computer models are wrong. Do they offer another solution? They are not going to. They're going to say, I'm wrong. But guess what? What's their solution? Well, I'm going to enlighten you right now real quick. They don't have a solution. And then E, emphasis. Science is ever-changing and emphasizes on better metrics, and science is needed in order to predict better climate change and future weather. Metrics. What are these metrics that we see? Metrics is the computers and the increase in technology. 100 years ago, there were not computers. Now we have the scientific capabilities and the methods and the observational skills to utilize computers for them. Now science is a appeal to reason, therefore reason is dictated to be pure empirical knowledge that is tested with computer models. It's like the Moore's law dictates that transistors would double in size every year. That's R, reason, transistors. Transistors are in processors. Processors are the brains of the computer. Okay, I built a computer and I know what processors are. So if you guys ever want help on a computer, call me. Processors are the brains of the computer, and their size and the capacity of transistors double every 2 years. Every 2 years. So that means if you have $2 in the bank, it will be 4. 4, 8, so on, so on, so forth. So imagine what we have now in the size at 2014, the capacity of transistors, to accurately predict weather events. So, based on the balance of my brief and the propositions that I have advanced in this argument, I believe that science, using beer, are able to accurately predict future climate events. Thank you very much.
Thank you. Now we'll cross-examination. Yes, sir.
Pull the screen down.
Screen down, please. Pull it to the right and it'll stay down. Jiggle it to the right and it'll stay down. There you go. Good.
Gotta get the right jiggle.
Stand kind of close to each other, please. Thank you.
I'm Nivian.
Hi, Nivian.
My opponent, he's been having a few BEERs.
Ouch.
You know, very generously, for the sake of argument, if I grant you every single point you just said in your opening statement, how does that prove that scientists use computer models are able to accurately predict climate events? I love science, we love science, I love it. I mean, it's great, it's perfect. That doesn't mean that everything scientists will do will be accurate. That's actually an...
Is there a question anywhere?
Yes, it's coming. Like, you didn't make any statements in your opening statement, I'm not going to make the next question. So how does if I grant you all your points, how does your opening statement prove that it accurately predicts future climate events?
As I clearly stated before, Moore's law doubles the transistor size every 2 years. So that means that every 2 years, computers have doubled the capacity of transistors to accurately predict these models. And also, if my opponent actually did research on the scientific process, testing is a key component in the scientific process. So you test something through computer models, per se, to predict future climate changes. We can adhere that it will happen by predicting a past. If you learn from your history, you can probably tell the future.
Okay, they are able to it. Moore's law says that it doubles every year. So it makes how many years do you think before they can do it? And it's common scientific consensus that Moore's law is going to break down. I mean, anyone if you're that good in computer studies, you should know that by now.
Well, I wouldn't use a computer 10 years ago or 20 years ago, but I use a computer that I bought.
But you said Moore's law will eventually do it, but the statement.
No, I didn't say it will eventually do it.
I
I said the technology increase every 2 years. So therefore, if the technology keeps increasing, we have more accurate predictions.
Yes.
This comes with the technology.
That means future. If it increases every 2 years or whatever, you're talking about that it'll happen in the future. We're talking about, are they able to do it? You're saying it's going to happen in the future, so that's why they're doing it well now?
No, that's not what I'm saying. I'm saying that it's accurate now, and that Moore's law, it will be even more accurate in the future.
How did you establish that it's accurate now?
Because in 1970s, the transistor's capacity of a processor was limited to 2. Now, the transistor's capacity is limited to 3.8 gigahertz. 3.8 gigahertz, that's 3.8 thousands
all you're saying is
of a megabyte.
All you're saying is it's improving. I agree with that, but you haven't
If you agree it's improving, then it would accurately predict scientific models.
It will accurately predict?
It will accurately. And
When?
Because, as your opposition stated, that it's from 70% to 30%, then in the future, it will be from 90%
so the
and
future,
10% error.
future. So you win this argument if we were having in the future, but
I'm not trying to win an argument. I'm trying to advance my government's opposition. That's up to the audience.
All right. I'm assuming the clapping was for me because I don't know. I didn't see anything of substance on the other side. I'm very tempted to form the debate that I actually written, but I'd rather talk about this a little bit. So just a few things that I would like to say is that there's nothing that An said that actually proves that they are able to accurately predict. He talks about Moore's law, and then I don't know if he doesn't give you guys enough credit, but he constantly talks about the future, and he says in 2 years it'll double, it'll double, it'll double. So I say, are you talking about the future? No, now. Like, I mean, it's just ridiculous. I don't even know how to argue with that. Second of all, he yelled out that this is a fact debate, not a policy debate, and then he says, my opponents don't have any solutions. I mean, if it's a fact debate, why are you expecting solutions from us in the first place? Another thing that I'd like to comment on is that this is a fact debate, and I don't think that he represented any facts regarding actual climate thing. Like, he just talked about how he loves science. We all love science. Science is great, and all that stuff like that. But it has nothing really to do with the topic today. I mean, he could literally give the same speech and add anything at the end related to science, and then assume like it has nothing directly related to the topic today. He constantly talked about the fact how science is improving, but I agree with that. But his job is not to prove to us that science is improving or technology is improving, but is to establish the fact that it has already improved enough to accurately predict models. I mean, I've been getting better at basketball for the last 2 years. That doesn't mean I can play for the NBA. I mean, it's improving. Obviously, it's going to improve, but it hasn't reached that point where it can accurately predict climate events. I don't think so, and that's the burden of proof that they have to do. And you know, this seems very easy to me, but I mean, 70% is just regarding the earthquakes, and he made it seem like 70% is the accuracy level of all of the scientific events. I mean, predicting tornadoes and stuff like that is much more difficult to do. And even if it is 70%, 70% is not that much. he would take 70% chances of getting into UCLA. If he jumps out the window and I tell him it's 70% chance that he'll survive, he's not going to jump out the window. Now, let me talk about some other points. Another thing is that Michelle and An both said that history repeats itself. There's no doubt that events will repeat themselves, but our job is to predict when, where, to what intensity, and I don't think they're able to do that at all. Michelle talked about how we have some, I could say more eloquently, like fundamental laws of how to determine what happens, like hot air rises, things like that. But what she failed to tell you is that we do not have fundamental laws regarding living things. So regarding rainforests and things like that, we don't know how much, we don't have any laws to determine how much carbon dioxide they're going to release and things of that sort. Fundamental laws are restricted to simply inanimate objects that behave in a certain way. So just to quickly go into some statements that I'd like to talk about, is that simply the weather forecast has been actually very inaccurate. This week it's been wrong 3 times. I don't think that that's a major climate event, but I'm just saying that if they can't even accurately predict weather forecast hours before it's happening, how can you accurately predict climate events in the near future? It's just ridiculous. And the argument is not even about the usefulness of science like if they can predict it, but if they can accurately predict it. And I think that my opponent should restrict themselves to those things. Even in Michelle's speech, he says, has successfully predicted several earthquakes. The fact that it has predicted some earthquakes is not, a definition of accuracy. I'm sure it predicted some earthquakes. Then she also talked about that it does not make it useless for, it does not make useless if errors occur. I mean, that's a whole totally different argument. I would agree with that point. But she is admitting in that point, if you read between the lines, that it is inaccurate, it has errors, and we should still use it. But she admits to the fact that it's inaccurate. The whole climate concept and determining is very chaotic. Chaos theory suggests that small differences in initial values results in more complex and more undeterminable outcomes. There's a lot of most of people might have heard of the butterfly concept, and it's that a butterfly can flap its wings, and next week, hundreds of miles away, it could cause a thunderstorm. It's how can you incorporate that in a computer model? The computer models, as accurate as they may be, they are slaves to the programmers who make them, and it is almost impossible to incorporate all the complexities of the world that actually contributes to the climate events. So no one is bashing science here. No one is bashing the use of science. It's simply that it is inherently very difficult to incorporate all the factors needed to accurately yield results. I think I've established that not only have my opponents not established that scientists can accurately predict, but that it's inherently difficult to predict accurate. Looking forward to the cross-examination.
Is that time? Thank you. Thank you very much. Chair will now entertain a cross-examination period of 3 minutes in front of the podium, please.
I wrote some questions. I intentionally left it up there so that we'll have a fair debate. So I'm going to ask you a couple questions. Is that okay?
Sure.
Okay. In your brief, you didn't. I'm going to take an exact quote from your brief. You said, all of that changed 100 years ago. This is regarding chaos. Scientists realized that they could understand how a system worked. That is, that they could understand the mathematical equations that described it. So, 100 years ago, did computers exist?
You want to ask me questions about what speech I gave, or what?
I'm asking questions about the evidence that you gave. Like,
What?
this is, I quoted from your brief. So, did computers exist 100 years ago?
Probably not.
Probably not, or not?
No.
Okay. So, Formula 1 and Formula 2 for your second, or mathematical equations from your source, okay? I'm going to show you the mathematical equation here. That is on the first page of your source.
Okay.
And I don't know if you can see that. You probably can't.
You should probably talk about things
Don't
that
you
the
think your
audience
source?
knows. So,
don't you
like,
think your source is a little dated?
No.
When did it come out?
Which source are you talking about?
The source I just showed you right here.
Dude, I can't read your handwriting. That's a formula. I don't know if that's a source.
Shinbot Troy.
Yeah.
So, what year was that?
1992.
1992. So, let me rephrase the question.
Yeah.
Don't you think your source is a little dated, since we're talking about 2014 climate change events?
Don't you think you should talk about sources that actually used?
You did use that. You said you used it. 1992 Shinbot
Okay, so
Troy.
you said because it's in 1992, it's automatically wrong.
I didn't say that.
What's wrong about
I
it?
asked you, don't you think your source is a little dated, yes or no?
No, of course not.
Okay, it's
doesn't
not.
matter.
1992
The
is not dated.
logic has to be applicable. It doesn't matter.
Okay,
if you said-
moving on because we're running out of time.
Sure.
Do you think? Okay, you said you're not a science basher. Is that correct?
Yeah.
Could you please tell us the 6 steps of the scientific process? I have the answer if you want to look at it and read it to the class.
No, I do not.
Okay. Could you please tell us the 6 steps of the scientific process? No, you do not.
So you
I am
think-
my cross-examination.
Okay. Because I'm not reading the 6 steps, that means I'm scientific. But okay.
If you do your research, you would know the 6 steps of the scientific process.
Okay.
I'm gonna clap for that because nobody else is gonna.
Okay, let's give him a nice round of applause. It's now time for the refutation period. 4 steps of refutation rebuttal.
Hi, Michelle.
Has everyone turned in their midterm?
Final.
Final? Excuse me. Has everyone turned in their final? Okay. 4 minutes.
Hi, Michelle.
Hi, Michelle. Real loud, please.
Okay, I'll just address one point that Madison said about rainfall simulation. I would like to directly refute that with something that I found. We have developed a sophisticated AI software in rain forecast, contrary to what you said, in the Atmospheric Research Journal in 2013 with a tool called the SVM, and this stands for the Support Vector Machines. And we use it because it's simple, it's fast to train, and it can be applied to data that's in certain places, such as a river basin, instead of globally. And it can be also used for other rainfall factors like downscaling and stream flow prediction. And what they did here was that they took data from 2009 to 2010 in the Madrid, Barajas, Barisonde, and they used new input variables that were randomly assigned to rainfall data. The SVM, unlike previous versions, is able to put in new predictive variables, including upper air sounding data, in addition to the traditional factors such as condensation, nuclei, water vapor, and vertical air movements. So it has shown an improvement. And how does the SVM do this? It learned how to make predictions as a classification tool. Basically, it's a math tool. And it recognizes patterns by partitioning all the data into these bucket lists for easier computation. And it discovers the largest separating factors between these bucket lists, and then these factors become its classification rules. So they took the SVM out for experimentation. They went out to the airport and they used yesterday's data to predict today's weather, so that's 24 hours. And they asked the machine to say whether there was going to be rain or if there was no rain. And they compared this against the real rainfall measurement that they actually went out to collect. And what are the results? The results are that they compare it to previous versions of neural computation-based systems such as extreme learning machines, and the multi-layer perception, which is the MLP. Okay. And that they compared all of these systems together on an ROC curve, which is the rate of true positives versus false positives. And then they found that the SVM had the largest area under the curve, thus outperforming all the other systems. So what I'm trying to say here is that we have been improving. There are previous versions of machine learning AI tools, and that the SVM is one of the newest one. And as you can see, that as very much. And for the reasons stated, I would say that scientists using computer models are able to accurately predict future events.
Thank you. Here next, now we'll recognize the leader of the opposition for a rebuttal, a 4-step refutation, not to exceed 4 minutes in length.
Hi, Madison.
Hi, Madison.
So they say that earthquakes are a climate event, and that she defined climate events as something that affects people. We disagree, because earthquakes and their models are based off of geological events, so these models are very different than what's being predicted for climate, so I don't think that they're comparable. They say that models can be use past events to predict future events, but these current models, I disagree, because they're not even being able to predict these past events. I brought up the IPC models that were tested against 4 major climate events from the past, and they weren't even able to get the basic climate correct of these events. And so if they can't predict the past events that have already occurred, how are they going to accurately predict the future events that are supposed to be occurring? They say that computer models are currently accurate and that there are some discrepancies and some errors, but we disagree. I mean, as currently as 2011-18, different models were compared and they were shown to be off by 46%, which I think is a pretty large amount, especially if these models are being used to determine decisions in the public arena and policies that are going to be affecting your daily life. And so when it comes to these models, I think that they should be accurate, more accurate than being 40% or 6 off. And then she said that in her rebuttal that SVMs are currently outperforming the predicted rainfall models of the past, but just because they're outperforming these past models doesn't mean that they are still being accurate or correct. They still have the issue that I brought up once again, where precipitation and cloud formation, they're not being able to accurately include these variables in these models, and when they have these issues, they're going to be off. And so for these reasons, you should side with the fact that scientists using computer models are not able to accurately predict future climate events. Thank you.
Thank you. Amen.
Hey guys, my name is On. Apologize for being a little aggressive. Apologize to Vivian. Sorry. But they say that earthquakes.
Oh, Nivian. I think you said Vivian.
No, I said Vivian. Sorry. They say that earthquakes are not related to climate change. We agreed on the definition that the brief is also in math. Brief climate change we define as a change in weather due to certain events. Certain events could be earthquakes. Earthquakes or tectonic plates. The magma moves. That affects the atmosphere. Atmosphere affects the sun. Rays coming down. Direct sunlight affects climate. They say that science is chaos. We disagree. Science is not chaos. Scientists use empirical data and testing to come up with reason. And if my opposition did a little research on the scientific process, there's a lot of hypothesis, testing, and theories that goes into the scientific process. So I would like to cite Nivian's source. Using sensitive dependence of chaos to direct trajectories in an experimental chaotic system, they related complex mathematical equations that were based off of computer models. In this brief, in this 1992 brief, as I showed Nivian, the mathematical equations, he said yes, they're there, and he totally ignored them. They say that the 1992 Shinbart-Troy data is not dated. I disagree. I believe 1992 is way outdated for current climate change events which occurred in 2014. Also in his brief, I quote, UCLA notes that 3 obstacles in your brief, observation systems, numerical models, and computing power, are all obstacles in the scientific models. Well, observation systems we have satellites, we have weather balloons, we have balloons that go up that measure CO2 data, and they say that these are obstacles in predicting climate change. We disagree. These are not obstacles. Models and computing power, we have the computing power as I explained through Moore's law. There are more transistors now than there have ever been for the last 30 years. That means we have more computing power and more processing power that has ever been since 1930. And he has completely ignored that fact. He even stated that 100 years ago, computers did not exist, and there was chaos in science. Of course there was chaos in science. Humans cannot mathematically equate certain equations. They only can calculate so much. That is why we need the use of tools, such as computers. Mankind, since the dawn of the ages, have been using tools to advance the betterment. For economic reasons, for societal reasons, and, unfortunately, for political reasons. So, for all the refutations and the propositions that I've listed below, I believe scientists using computer models are able to accurately predict future climate events. And just for the record, I did not have BEER. But I did have BEER in forms of benefits, the emphasis of educators using reason. Thank you.
Thank you.
This is a fact debate. BER benefits don't really matter. The social repercussions doesn't really matter. First of all, I don't agree that lying to people about how accurate something is just to convince them has any benefits. But even if it did have benefits, the benefits don't really matter because it's a fact debate, and we're debating if they're accurately able to predict them, not if there's benefits. Even if it caused destruction, even if it destroyed the world, the facts remain the same. It doesn't really matter. I think that's the only point I addressed, the one that he said I haven't addressed, and that is that we have more transistors and technology has been getting better. Just because it's getting better does not mean it has reached the point where it's able to accurately predict these things. I've said that before. I gave you the example. I've been getting better at basketball. That doesn't mean I'm going to play for the NBA. It doesn't matter if they're getting better. Obviously, they're going to get better, but my opponents have to convince us that they've reached a position where they're accurately able to predict. Second thing is that I don't understand the big deal about the earthquakes. Even if we say earthquakes are climate events, I don't understand how that makes the opposition's case any stronger. It's only 70%, and they're trying to give to you guys like the statistic that 70% is like all the considering all the events. It's only earthquakes, and that seems pretty high to me, anyways. They said, I said science is chaos. I disagree because I did not say science is chaos. I think he's just making up things. I'd like to wish he was having some BER, because if he's acting this way without BER, I don't know.
God.
Yeah, so,
Okay.
Okay, I got a minute left. I just want to say, I just want to express my sympathies to the opposition, to our opposition, because this was a very difficult thing for them to do, because I went online trying to find some facts about how they've been accurately able to predict it so I could refute it, and I couldn't find anything, and you can tell by their speeches and their rebuttals and the expressions on their face that they weren't able to find anything either. They had to resort to general arguments that had nothing to do with the topic. They had to use things like it's improving. They just had to talk about benefits. They had to talk about everything that they possibly could, besides the fact that scientists are able to predict climate events. I know I've been saying the same thing every time I got up here, but I don't have much to say because I disagreed with them on my opening statement, and since that position they haven't provided me a single point that I would further like to disagree with. For all those cases, you guys know what to do.
Thank you very much. It's now time for the audience to look over their notes and to individually make a decision.
Did you want to hold on to
I guess so, yeah. I'll put them in my thing down here.
or did you want me to hold on to it?
No, there's no reason to. I'll have them here in the front.
These are extra.
Okay, but you look through these and none of them were clamp-hold or crimped.
One was wet, but I had it been good.
Yeah. He needs to rest. He's crying.
Yeah, that's the one.
What?
So this was the midterm.
Yeah, I want to make sure I got them all filled out. Yeah, and yeah, I'll record it.
It's still short on discussion forum.
We're still short on that.
The post online discussion forum.
Okay, remember to post your decisions online. That is if you want the points and credit for that. Free country.
Is it extra credit?
No, it's not extra credit, it's credit. It's part of the credit. Yeah, you have to post your
So when do we have to post all?
I think we're going to close them earlier, especially the
10th
first
week.
time.
Yeah.
By 10th, end of 10th week.
Okay.
I don't know so far, good.
I haven't looked over them.
I don't have to run my hands, right?
No, not for yourself.
Just slide over that way a few feet.
But you should write for the other people.
Yeah, I wrote for everyone else.
So it's going to be unlisted then?
Yeah.
Wouldn't be off, but unlisted.
Yes.
Won't be public.
Yeah.
Did you hear that? It's not going to be public because she doesn't want it. It'll be, you'll still get a link.
That's why she was so.
Anybody have a stapler? Yeah, good man. Bring that stapler every time. Yeah, extra credit.
That's up to you.
Has everyone voted? No. You voted?
He was going to say, I had a couple. I knew at the end I said that.
I knew he was going to say that.
I expected it.
What? Whatever you want.
I was saying, I would have done the same exact thing as you. Like, you kind of I was waiting for you to say that.
I was waiting for you to say that. So at the end I would say that.
Let's see, can I talk to you briefly after class? Briefly after class.
Yeah, I need to like pull over.
So Michelle wants to sit in the audience. She doesn't want to sit up there. Is that okay?
What?
She doesn't want to sit up there. She wants to sit in the audience. Is that okay?
Who's that?
Michelle.
Why is that?
Not feeling comfortable.
Okay. Free country.
Oh, yeah.
Thank you very much.
Oh, Tom, share that with your partner that I gave you. Same with you. Share that CD with your partner. Yeah, the DVD.
Yeah, I appreciate that. Thank you.
Okay, yeah.
Yeah. It's already in the... Huh? It's already in the... Okay.
In a 20-4 decision, the decision goes to the opposition. Let's start with Danielle. Oh, we're going to start over here. Sorry.
Hi, I'm Sam.
Hi, Sam.
So both sides did great. Very well structured.
Oh,
and
one more.
This is your second debate, so I like your
21.
style with the beer. And then you slammed him with using his own beer as like part of your argument. But overall, I voted for opposition, and that's because while you guys had good arguments, it was kind of off topic and weak. Your facts are weak in that you mentioned earthquake so much.
Yeah, well, the problem was we split up the work. So I was supposed to do the psychological analysis of why we doubt science, and she was supposed to do the scientific analysis of weather predictions.
She actually had a whole page she didn't get to that was really good too.
Okay.
With more facts. Just.
So that's why it was like kind of off.
Is she gone or?
Yeah, she went to the back.
Well, just based off what I saw, I'll just say that, yeah, with the earthquake thing, and then the opposition was saying that's not enough because you're just talking about earthquakes, and then what about everything else? So I was basing it a lot about that, and I liked Nivian's argument by analogy with the whole basketball thing. Like, just because I'm a good just because I play basketball,
That killed me.
Doesn't mean I'm gonna make it to the NBA. So that was like a nice analogy there that caught my attention.
Just real quick for later, Michelle, when you're listening to this tape, if you do a better time allocation, if you know that you only have 7 minutes and you've got 4 big arguments to cover, then you need to time them under time conditions at home and check to see that you can only do 2 minutes. She spent much too much time on earthquakes and not enough time on the bottom half of her brief. And she had much more information on weather predictions and other things, but she didn't get to it.
In defense of Michelle, we met up an hour before we practiced our speech.
Mm-hmm.
And I did a little exercise where I didn't tell her the time, like I didn't give her the signals, and she still ran over time. So she had to pick like the topics, and it was my fault because she asked if the earthquake was okay. I was like, yeah, it's good. Go with what you're comfortable with. And so she picked
earthquakes. Yeah.
Well, I persuaded her to pick earthquakes, so that was my fault.
Okay, fair enough. Also, in On's defense, from another class of mine that he had, I like the use of acronyms for for helpful voting issues because it's. I'm sure if nothing else, when you think of on, you're going to think of beer. And, whether you remember what the acronym stands for or not in this particular debate, but I appreciate the effort to find an acronym to vote for voting issues. Yes, please.
Hi, my name is Arditha.
Hi, Arditha.
I voted for the opposition because I think
Is
it's
this
hard
yours
to
making that noise?
argue
Can you make it quiet because it's picking it up on that?
because it tolerates no error and all that, so it's really hard to the opposition. And for Michelle, I know how it feels to have a small voice, and it's really hard, and you did a very good job, so good job.
Okay, thank you. Next.
Hi, I'm Priscilla.
Hi, Priscilla.
I voted for the opposition mainly because I think it's a fact debate and the opposition provided more references, facts, and data to show the computer models are not accurate. But I think the government has also done a good job, especially on how to show the computer models are accurate or the science stuff from the other angle other than just providing facts. But I think if there are some facts or some more data, it can be better.
Right. Okay, thank you, Priscilla. Yes, please.
Oh. Hi, I'm Ed.
Hi, Ed.
Okay. I won't speak to Michelle, I guess. But,
We'll say it anyway, the recording's gone.
okay. Well, I thought the evidence was really good. I thought that she had a lot of strong sources and detailed evidence, but I didn't understand any of it. And I don't know, I didn't know what MA and MAMSC was, and I felt like it needed to be explained. So, it just seemed to me like, oh, that sounds really good, but I don't know what any of it means. So I also just didn't agree with the definitional issue. I felt like earthquakes are not a climate event, so I just had to go with the opposition on that alone. And then, but I mean, I thought like her speaking was strong, like she had all this good information. And then Madison, I thought you did great. You were, just on point on everything, and you really had a lot of strong evidence on your side, and you brought up all the points you needed to bring up, and so it was just solid. I really like your speaking style. You're very entertaining. I love it. You're very confident. You're very strong in your voice.
I didn't have Kevin this time.
The only thing is that, so you were speaking to get back to us in the beginning. I didn't like that. I felt like, you didn't really link. You didn't link a lot of the stuff you were trying to argue your points with. You're telling us that earthquakes are caused by the climate, but I didn't see any link. It's kind of like you just told us, and you didn't cite any evidence or anything. Okay. Yeah, Nibian, I thought you did a good job too, calling out all those things that I just talked about. You called out all the right stuff. And I really liked your process, your argumentation, but you didn't have any evidence either.
No, I